October 17th, 2024 marks the 75th year of the commencement of the Snowy Mountains Hydro Scheme. I'm Paul Michael Angus, a mechanical and civil engineer in Australia's water sector. Come with me as I explore the timeline, the components, and the challenges faced throughout its construction, as well as celebrate the amazing elements of this engineering wonder. From the previous episode, we've now observed how water can enter and leave one half of the overall Snowy scheme, i.e. the Snowy-Murray development, which itself sends roughly 40% of the diverted flows of the scheme towards the Murray River via the Swampy Plains River downstream of the Cancoban Pondage. These waters, through this process, pass through the 3 hydropower stations, which contribute roughly 1.56 gigawatts of the initial 3.74 gigawatt total nameplate capacity of the Snowy scheme, noting that I've left the mini hydros off that list due to their scale and small contribution. The second half of the scheme, i.e. the Snowy-Tumut development, the focus of this last episode, receives the remaining 60 or so % of these diverted flows, sending these through 4 main hydropower stations as well as the newer Janama facility. Like the above, for now, I've left Snowy 2.0 off that list, given that it's under construction and subject to ongoing change and refinement. It's from this point, though, that we now go to the top of the Snowy-Tumut development, Tantangara Reservoir, the first point where water is impounded and the diversions into the Snowy-Tumut scheme commence. Situated roughly 1,200 metres above sea level, the 45-metre high Tantangara Dam wall holds back the upper Murrumbidgee River, creating the approximate 240 gigalitre reservoir which feeds Lake Eucumbene, or the upcoming Snowy 2.0 complex. From the reservoir, water enters the Murrumbidgee Eucumbene tunnel and flows some 16.6 kilometres through a 17% lined tunnel to the outlet at Providence Portal at Lake Eucumbene's north. Lake Eucumbene is formed by the dam situated some 20 kilometres south of Providence Portal. This 116-metre high earth-filled dam impounding the Eucumbene River, which formerly would join the Snowy River, and creating a 4,400 gigalitre storage for the total Snowy scheme itself. Now, disregarding the link back to the Snowy-Murray development, water from this reservoir would typically leave this part of the system via the tow bar inlet-outlet structure, around 6 kilometres north of the dam wall itself. Once through this structure, water would flow towards Tumut Pond Reservoir via the Eucumbene-Tumut Tunnel, of which 28% or so is lined. Now, as previously noted, water in this tunnel can flow in reverse when runoff is high in the upper Tumut River. The Happy Jacks Dam and inlet shaft permitting this to occur via a cylindrical gate shaft at the base of the intake system. This operation serving more as a storage mode in Lake Eucumbene rather than the source-to-sea journey of water through the Snowy-Tumut development. Travelling through its journey out of the scheme, water will go 22 or so kilometres through the partially lined tunnel and come out through the submerged outlet in the Tumut Pond Reservoir, which can be anywhere up to 60-ish metres beneath the dam's maximum operational level. Now, it isn't just water from Lake Eucumbene which enters the Tumut Pond Reservoir. The Tuma Dam impounds the river of the same name and permits its waters to be diverted from its former catchment into the Snowy-Tumut development at the same point as waters from Lake Eucumbene. Tuma Dam, an earth-filled dam like Eucumbene, roughly 67 metres in height, holds back up to 25 gigalitres of water which can be sent to Tumut Pond via the Tumut Tunnel, roughly 14 kilometres in length. This particular tunnel differs from others in that it isn't particularly straight, mainly due to it having 4 intermediate intakes along its full alignment. The outstation, Ogilvy's, Deep and Burns Creeks all feed into the tunnel below the upstream inlet control structure near the Tumut Dam. Each intake system having a smaller dam or weir alongside an intake shaft comprising of numerous automatic siphons. These two main diverted inflows, in addition to the natural runoff of the Tumut River, are what fills the Tumut Pond reservoir behind the concrete arch dam. The dam structure being some 86 metres in height and holding back up to 50 gigalitres of water, which feed the power stations below it. Almost all water will be diverted to these power stations, which operate in tandem via the Tumut 1 pressure tunnel, but I presume that under very rare circumstances, water may still flow over the spillway of Tumut Pond Dam and back into its natural course along the Tumut River before reaching the Tumut 2 pondage. Most water, as noted, will travel through the 2.4 kilometre pressure tunnel towards Tumut 1 power station before falling roughly 250 metres after the upstream surge chambers to the machine hall below. The water then making its way through one of four 80 megawatt turbine units and leaving via the lower surge chamber and tailwater tunnel linked back to the Tumut River, some 1.5 kilometres upstream of Tumut 2's dam wall. The Tumut 2 dam and pondage, as described in previous episodes, aren't very large at all, being only 46 metres in height and having 1.5 gigalitres of active storage. The main purpose being to provide sufficient buffering between the two power stations that typically run at the same time. Unless rare circumstances permit flow to go over the spillway, water from here would enter the Tumut 2 pressure tunnel via the dam's outlet structure and travel some 4.8 kilometres through a fully lined pressure tunnel towards the Tumut 2 facility. Along the way, though, receiving some additional flow from the 8 Mile Creek aqueduct and inlet at the upstream surge chamber. Once downstream of the surge chamber and spillway structure, water will fall in elevation once again, a further 225 metres into the machine hall of the Tumut 2 power station. It will enter one of four 70 megawatt turbine units and then, like flows leaving Tumut 1, rejoin the natural path of the Tumut River flowing through the lower surge chamber, the tailwater tunnel, and the associated outlet structure. From here, it enters the Talbingo Reservoir, upstream of the Tumut 3 complex. Talbingo Reservoir is the third largest gross storage in the scheme and has the largest dam of all built by Snowy Hydro, roughly 160 metres in height and creating an active storage of 160 gigalitres, which can pass through the Tumut 3 power station. This storage and its power station all reside at a point within the Tumut River Valley where the mountain range itself has been radically transformed to impound the river and the diverted flows from the upper Tumut development. Presumably, water likely never overflows the earthen-cut spillway channel, largely continuing its journey through Tumut 3 and into Janama pondage below, where, depending on the time of the day, it is either released downstream or sent back up into Talbingo via the 3 pumped hydro units within the complex. Here, it's quite possible that the water's journey does a few backsteps between Talbingo and Janama pondage, and in the foreseeable future, with Snowy 2.0 in operation, it's possible this water could restart the full Snowy-Tumut journey to date by being pumped up to Tantangara, or take a shortcut, bypassing the upper Tumut development itself by going straight from the uppermost reservoir into Talbingo below. Regardless of whether it does one lap through the scheme or 100, water will eventually be released from Janama pondage, most likely via the new Janama power station, which, as described in previous episodes, was added to the scheme to reclaim lost energy, which typically goes through the control gates of the Janama Dam. From Janama pondage, water has now made it to its last stop within the Snowy-Tumut flow path, Blowering Reservoir. The reservoir itself is created by the dam of the same name, an earth-filled dam roughly 112 metres in height, requiring the second largest volume of material of all earth-filled dams of the scheme. The structure being located at the very edge of the mountain range before it opens up into flat plains to the north. Unlike Cancoban Dam, Blowering has been fitted with a hydropower station due to its height, with water being able to leave the reservoir via the former diversion tunnel from the dam's original construction into a single 80 megawatt turbine, or, in the event of this not being operable, via a second valve assembly used for irrigation releases downstream into the Tumut River. Once released, these waters will follow the Tumut River to its junction with the Murrumbidgee. From there, it'll navigate its way through southern New South Wales until it meets the junction point with the Murray River along the New South Wales-Victoria border. From there, it'll continue on with waters from the Snowy Murray development in the scheme's south, all up diverting anywhere from 2 or more thousand gigalitres of water every year, roughly anywhere between 3 to 5 Sydney harbours as a comparison of flow variability. What doesn't get drawn off for irrigation between the downstream states will make its way through the locks and barrages of the Murray River towards the river's mouth in South Australia. It's here that I'll wrap up this series of episodes, the last 2 hopefully providing some insight into the water's journey from its original course through Victoria, under the Great Dividing Range of southeastern Australia, and into the rivers towards South Australia. I'll admit, these episodes do only focus on the facets related to the engineering works and the planning of the scheme, and fully acknowledge that there's also material available for a whole separate series of insightful episodes into water management, environmental values, and also where improvements could be implemented. For now though, thank you kindly for joining me along this journey, and I hope it gave you some insight into the Snowy scheme, its history, and where things appear to now be heading into the future. I'm Paul Michael Angus, and thank you once again for watching and celebrating the 75th anniversary of the commencement of the Snowy Hydro scheme.